Hey guys, this is Einar. I hope that you're doing great today, and welcome to this tutorial where we're going to be talking about the effect of outliers on the arithmetic mean. Now, to begin with, we're going to talk a little bit about the arithmetic mean and what it is. Wikipedia defines it as the central tendency of a collection of numbers taken as the sum of the numbers, that's this part of the formula, divided by the size of the collection. Well, that's this part of the formula. Used with other words, you could say that this is the sum of the values of x for a population of individuals that we have been investigating according to some variable, and this is the number of individuals or observations that we have in our population. So that's another way of describing it, and this, an x with a bar over it, is the arithmetic mean. So let's move on. Our problem then. Well, the arithmetic mean is known to be unsuitable for distributions that are highly skewed, and some example of variables like that are income, number of friends, number of sexual partners. Now, what is the problem here? Well, in the terms of income, we have a large group of people that have an income between a certain interval. Like most people have an income in Sweden, but I'm guessing wildly now. They have an income between 18,000 kronor and 25,000 kronor. That's where most people are located. But then we have a couple of people that have extreme incomes, extremely high incomes. And what that does is that they will pull up the arithmetic mean because of the characteristics that we're going to investigate in our experiment. But we have a few people that have extreme incomes as compared to the larger group of people. The same thing goes for friends. Oops, I'm sorry about that. Sorry about that. Yeah, the same thing goes for the number of friends that people have on Facebook, for example. Some people have like 4,000 friends on Facebook, and some people have only 100 friends on Facebook, but most of the people have between 100 and 500 friends on Facebook. So if we were to draw that distribution, it would be highly skewed with a long tail in the end, where a small number of individuals are located. And this same thing goes for a number of sexual partners. So what causes these highly skewed frequency distribution? Well, the causes, social causes for them, that's a completely different discussion. So forget about that. But we're going to be talking about our outliers that causes these skewed distributions mathematically or statistically. So that's what we're going to be talking about in this case, just so you know that. The arithmetic mean. Okay, our experiment. The purpose of our experiment is to investigate the effect of outlying observations on the arithmetic mean. Okay, that's our purpose, that's our problem. The method. Well, we're going to visualize the data in terms of distances from zero using lines. Now, this is an idea I had because I really like to, or somebody's probably done it before me, but I really like it because I like visualizing things. And what x values are really are distances that an observation has from zero. So if you draw each observation's x value using lines, with distances from zero, you can get a really neat way of describing data sets using them as distances. So if we do that here, you have our experiment set up here. So we have a small population with 3 observations, 1, 3, and 9. I don't know what this is, I just made it up, but let's say it's number of friends. So this person here has 1 friend, this person here has 3 friends, and this person here has 9 friends. So this person is 1 friend from 0 friends, this person is 3 friends from 0 friends, and this person is 9 friends from 0 friends. And if we had calculated the arithmetic mean, this would end up at 4.33. I've done this from before. If we draw this as lines, you will see here we have 1 person here that's located way at the bottom, 1 person from 0, this person is 3 friends from 0, and this person is 9 friends from 0. So, and these lines are exactly proportional. I've drawn them just visually, just to make a point. If we were to draw out our arithmetic mean, it would be located somewhere here, which is kind of in the middle of this distribution. It's in the middle of these observations. I mean, this is the middlemost observation, so this would be the median, but it's a still pretty good description of the center of our data set in terms of this x values that we have here. However, if we have another distribution with an outlier, so it's the same as before. This person has 1 friend, this person has 3 friends, and this person has 9 friends. Okay, so far so good. But then we have this outlier where a person has 33 friends. If we were to draw this, it would look something like this. This is identical to our distribution from there, but then we have this added distance of 33 friends from 0. What effect is this going to have on our arithmetic mean? Is this still going to be a good measure? Well, we're going to have to calculate it. So what we're going to do now is we take each distance that each of our observations have. So this is our first one with 1 friend, 3 friends, 9 friends, and then 33 friends. You can see I'm adding them up here because we need a sum of x for our formula, and that's what I've done here visually too. I've just added up the distances. So this is our total distance from 0 when you add up all the distances that our observations have, and that equals to 46. So our sum of x is 46. If we then take this and divide it by the number of observations we have, n, which is actually the arithmetic mean, you can see the formula here that I showed you in the beginning. We divide it up into 4 pieces, this total distance, we get our arithmetic mean, which is the distance, of any of these, the distance between any of these 2 points really, but I took the first one just to make a point. So 46 divided by 4 is 11.5, so this distance is 11.5 friends from 0. So that is our arithmetic mean. Let's compare it to our distances. You can see here that this is not located in the middle of our data set. So all of a sudden we're pulled up here, and we're pulled up closer to this observation with 33 friends here. So this outlier has a pretty huge effect on our arithmetic mean, which was 4.33 from before, if you remember. Oops, I got a text there. Sorry about that. Okay, so if we put these all on the same line that we had from the beginning, you can see here again that this 11.5 is located way above our 3 observations here. So my conclusion is that outlying observations will have a disproportional influence on the arithmetic mean if you're looking for the center of a set of observations. And what do I mean by disproportional? Well, I mean that this person here with 33 friends has a larger effect on the arithmetic mean than this person with 1 or 3 or 9 friends has. So you have to be careful when you use the arithmetic mean, especially for skewed distributions. And finally I'm going to show you another way of visualizing this, which I think is really nice. You can see here that this top distribution here, this is a frequency distribution. So as I move up here, I have more people, more higher frequencies of people, and this is our x variable. So this is for people with 0 friends, this is for people with 1 friend, if that was my example. And it moves on upwards here. And we can see that most of our people in our population here are located here, and it's perfectly symmetrical. So that means that the center, the most common observation is going to be right here in the middle. Most of the people have these many friends. If it's perfectly symmetrical, that's also what the arithmetic mean is going to end up at. And it is going to be the median because it's the centermost observation. So in a perfect symmetrical little world, you wouldn't need to use these measures at all. You could use the mode or something. But that's not what reality is like. This is income, this is number of sexual partners, this is number of friends, and lots of other distributions. And you can see that this will have an effect on our parameters. So the mode, for example, is still going to be there right in the middle. Our median is going to be pulled up slightly up towards our top here because it's pulled up by these extreme observations. So the middlemost observation is not going to be here in the middle. And the arithmetic mean is most highly affected, influenced by these influential or outlying observations. So that is why people say that you should be careful when you use the arithmetic mean for highly skewed distributions. I encourage you to play around with this. Try just drawing on pen and paper and calculating your own distributions to look what effect this has on our measure. Also try using Excel in the exercises we have in our earlier tutorials. So have some fun with this. Thanks for listening to me and have a really great day. Okay, bye bye.